We are here today to review some geometry theorems that you should know from days gone by, perhaps grade 8 or grade 9. So here we are in grade 10 reviewing these angle theorems. First of all, we have complementary angles, and it's not just that they're very polite to one another. It actually means that our angles, I have to do my best to do this without a ruler. If we have a 90-degree angle and we were to cut that into pieces, so right now I've got 2 pieces, but I could potentially have 3 or more. If we take a look at each individual piece, I'm going to call this angle A, and this angle B, and this angle C. So these pieces, they are going to add together to be 90 degrees, because the whole thing collectively is 90 degrees, and that's what makes them complementary. They add to 90 degrees there. So you can write in beside here on description that angles that add to 90 degrees are complementary to each other. Supplementary, on the other hand, again, if I had a ruler, I would use a ruler. Well, I have a ruler, I just can't use it on the iPad. If we have a straight line, and then we break that straight line into various parts, those angles, those individual pieces, A, B, and C, are called supplementary angles, and they are going to add together to be 180 degrees. So we can make a little equation out of here. A plus B plus C equals 180 degrees. So if I knew A and B, I could be able to solve for C. Opposite angles occur when you have 2 straight lines intersecting each other or crossing each other. The angles that end up being across from each other will equal each other. So the angle here, which I have marked, will be the same or equal to the angle on the other side. And similarly, I could have the angle over here. I'm going to call that one B. It's different. It's going to have the same measurement as this angle across from it or opposite to it, across those the intersection point. We also have pairs of supplementary angles. So if we look at this, we have, that was not what I intended to do. If we look at this, we have a straight line along here. So that straight line means that angle A plus angle B would have to equal 180 degrees in this case. The fourth one we're reviewing is the fact that the angles in a triangle are going to add together to equal 180 degrees. So the angles in a triangle will add together to equal 180 degrees. So I'm going to draw a triangle here and label the corners as an A, a B, and a C, and collectively A plus B plus C will equal 180 degrees. So we can use that to help us solve for unknown angles as well. We also have the fact that we could have isosceles triangles, and an isosceles triangle just means that 2 sides are equal in length. And what that means is that the angles across from the equal sides will also equal each other. So if I look at what I have here, I have my equal side right here. It's equal to this side. And that means then that the angle across from the side, so matching this up, the angle across from the side, that angle, which I'll call A, is also going to be equal to the angle across from this side, which is equivalent, so I will also call it A. So A is equal to A there. So basically I would have 2 A's plus this third angle up at the top. They collectively would have to equal 180 because of the angles in the triangle have to add to 180. A third triangle one that we can talk about is the equilateral triangle. Now, if we have an equilateral triangle, that just means that all 3 sides are equal in length. And because of that, it starts out like an isosceles triangle. I know that the angles across from the 2 equal sides that I've marked so far would have to equal each other. But once I mark that third side as being equal, and if I were to turn my triangle, then I would have this side across from that one being equivalent to, say, this one here. Okay, so if I were to tip that triangle, rotate that around clockwise by about 120 degrees, I'm going to end up with these 2 angles being equal. So it actually makes 3 angles equal to each other. And if we know that all angles in a triangle add to 180, I'd really take that 180 and divide it into 3 equal groups, and that's going to give me 60 degrees. So each angle in an equilateral triangle will equal 360 degrees. Okay, so those are our triangle ones that you should know. And then the last 3 that I have are the parallel line theorems. So these last 3, the corresponding angles, alternate angles, and co-interior angles, have to have parallel lines.